Hello everyone, myself Nitil. Today we are going to see about 3D printing in construction and Internet of Things. Let us go to introduction. C3DP construction 3D printing refers to the process of building structures layer by layer using automated machines such as large-scale 3D printers with materials like concrete or other construction elements. This technology allows for the creation of complex architectural shapes that would be difficult or expensive to achieve using traditional methods. Role in modern construction efficiency. It reduces the need for manual labor and speeds up the construction process. Cost effective by eliminating framework or under reducing material waste. C3DP can lower overall construction cost. Sustainability. 3D printing often uses materials sourced from recycled or construction waste, making it an eco-friendly option. In customization, it enables architects and engineers to design highly complex and customized structures with less concern about the additional cost or time for unusual shapes. IoT refers to Internet of Things in construction, refers to a network of connected devices that collect and exchange data through the internet. In construction, IoT devices include sensors on machinery, materials, and equipment that can communicate with central systems in real time. Smart operations. IoT allows construction managers to monitor the progress of the construction site remotely, receive data on equipment performance, and even predict potential issues like equipment failures before they happen. Automation. Through IoT, construction sites become more automated. For example, 3D printers and other automated machines can adjust their operations based on real-time data received from IoT-enabled devices, leading to more efficient and precise construction. Let us discuss about on-site versus off-site 3D printing. On-site CD3DP, on-site 3D printing directly at the construction site, reducing transportation costs. Off-site C3DP components printed in a factory, then transported and assembled on site, allowing for more controlled production. Let us discuss deeply about on-site 3D printing and off-site 3D printing in more particular. On-site 3D printing involves the direct construction of a building or structure at its final location using large-scale 3D printers. The printer is installed at the construction site and the structure is printed layer by layer. This method eliminates the need of to transport large prefabricated components, which can be logically challenging and expensive. On-site printing offers several benefits, including reduced transportation costs and ability to make real-time adjustment to the construction process. Since the structure is printed directly at the site, there is no need for additional assembly, reducing labor cost and time. However, on-site 3D printing comes with its own set of challenges. Setting up large 3D printers at the construction site can be complex and costly, as the equipment must be transported and installed. Additionally, on-site printing is subject to the environmental conditions such as weather, which can disrupt the printing process. Rain, wind, temperature fluctuations can slow down construction or affect the quality of the build. Moreover, the construction site must have enough space for printer to operate efficiently, which may be a limitation in densely built urban areas or confined spaces. We come to offsite 3D printing. Offsite 3D printing, on the other hand, involves printing components in a controlled factory environment. These components are printed with precision and quality, benefiting from the stable conditions such as temperature control, absence of environmental disruptions. After printing, the components are transported to the construction site where they are assembled to form the final structure. This method is particularly advantageous for ensuring high quality construction, as the controlled environment reduces the defects and allows for better material handling. While offsite 3D printing offers the advantages of quality control and independence from weather conditions, it does have some drawbacks. One major challenge it is the cost of transporting large components from the factory to the construction site. For distant site, transportation can become expensive, and specialized equipment such as cranes may be required to assemble the printed parts, adding to the overall cost. Additionally, offset printing leaves little room for flexibility and design changes. After printing, the model I started would require reprinting components, which could lead to delays and increased cost. Despite these challenges, the efficiency of factory-based production and the potential for rapid assembly on site, making offset 3D printing an attractive option for many large-scale construction projects. Challenges in cost calculation for C3DP: dual nature, lack of standardization. In the dual nature, C3DP combines industrial and construction product characteristics, complicating cost calculations. In lack of standardization, no established pricing system for 3D printing structures, unlike traditional construction methods. Influencing factors in cost calculation for C3DP: labor, machine, and material cost. Key cost elements in both on-site and off-site C3DP: framework and weather impacts. C3DP eliminates framework cost and it is less affected by weather conditions. In cost structure in offsite C3DP: printing stage, transportation, assembly. Cost includes materials, labor, machine depreciation, and energy consumption. Transportation cost associated with moving the printed components to the construction site is much more difficult as compared to the on-site assembly. Labor and equipment cost for lifting and assembling the components on site. Cost structure in on-site C3DP: labor, material, machine use, site management. Labor consists of cost for on-site personnel, material cost of the printing materials, machine use cost associated with operating the 3D printing equipment, site management site management, fees for overseeing the on-site printing operations. Cost comparison: traditional versus 3D printing construction. Traditional construction labor intensive, requires frameworks, scaffolding, and temporary structures, whereas 3D printing construction reduces labor, minimal materialistic waste, faster construction, but higher initial investment. Industrial versus construction product characteristics in C3DP. Offsite C3DP resembles an industrial process with batch production in a factory. On-site C3DP aligns with traditional construction practices with the entire building produced on site. Advantages and limitations of C3DP. Advantage: cost savings, reduce labor, material waste, faster construction as compared to the normal traditional methods. Complex designs: we can create a complex designs as required to the which reduces the labor on which will long live as compared to the normal concrete materials which are used till now. Limitations: high initial setup costs, need for specialized machinery, limited material availability, lack of standardization. The future of 3D printing and IoT in construction are growth potential and role of IoT. Growth potential consists of advancements in technology and decreasing cost, while it drive the widespread adoption of the C3DP. The role of IoT contains: IoT will continue to enhance automation, data monitoring, and overall smart construction ecosystem. Thank you.